There's enough on this page that you'll go from an A to a B if you don't get it. So memorize it, draw it, whatever you need to do to understand what's going on here. This is important. That's all I can tell you. All right. Know your gases, know your numbers. But more importantly, this is the whole picture. This is the respiratory system. It includes everything I've talked about for the first 50 minutes in here today. Inspired air. HAP's atmosphere. How do we inspire? We contract the diaphragm. We change the volume size, which changes the pressure size, which causes this. So this little blue arrow right here, can you write a little narrative about what this blue arrow means and how it happens, why air flows in? You got the nasal cavity, you got the tracheas, you got the windpipe, trachea, bronchi, etc. Diaphragm, pressure, volume changes. That little blue arrow means a lot. There's a lot going on at that blue arrow, and it just goes, whoop, this is how it happens. So you got to put it all together. This is the summation or the summary of the whole entire thing. When we look out here, we call this blood systemic arterial blood or systemic blood in the arteries. Is it oxygen rich or oxygen poor? It's oxygen rich. This is a tag along from AMP2. We already covered this. What is carrying most of the oxygen? Hemoglobin. And there's how many binding sites for oxygen on hemoglobin? 4. Is this all relevant? Sure it is. Sure it is. All right. So if it's fully loaded, we get a PO2 of 104. That means it is oxygen-rich blood, and it's going out to the tissue. Tissue is doing what? Cells in my big toe.
Metabolizing.
They're metabolizing. You learn this in Biobond, you learn this in AMP1. Can someone give me the 4 products that we see in metabolism, please? Heat. Water. ATP.
Lactic acid.
CO2. Ding, ding, ding. That's the big one. CO2. These cells are working. They're giving off CO2. Now what's the major trigger for breathing? CO2. CO2 levels, not O2. They're actually monitored and looked at in the cerebrospinal fluid, the amount of CO2. We carry CO2 back. We know oxygen was bound to hemoglobin. How do we get CO2 back to the lungs? Bicarbonate. The number 1 factor carrying CO2 in our body is bicarbonate ion. HCO3 minus. There's no curves like this, but they are relevant. I've already told you the 2 factors that causes the affinity changes for hemoglobin and oxygen are temperature, number 1, and number 2, acidity levels. How about this picture? I love it. It's on the text. I love it so much that this picture's on the text. And I did something like, let's just white that out. You'll have to fill it in with the correct answer. It's matching. I made it a little easier for you. All right. So you got 4 answers down below. You got to figure out where they go up here. But why I like this so much is because it's at the tissue. Let's actually go to the next one. Come back to it. Alveolus. Man, we've covered all this. Oh my gosh. PO2. This is where you got to put it all together. If you don't do it today, you got 5 days, which is beautiful. You got 5 days. It's supposed to be 80 tomorrow. I don't think you're going to be inside in the library studying anything. All right. So have fun, but then work hard. PO2 104. Simple squamous cell. Endothelial cell. Basal lamina. That's a respiratory diffusion membrane we talked about earlier today. Y'all with me on that? PO2 104. PO2 in here. Just came from the tissue. 40. We're going to move it. All right. There's a big arrow. This big arrow means something. It means that most of the oxygen moves through this pathway and binds to hemoglobin. Y'all with me on that? Good. It's a big one. There is some dissolved in plasma. Those are the only 2 real mechanisms we use to transfer O2. You got that? So if I told you 98% of oxygen is carried by what molecule, you'd say what? Hemoglobin. That's the question. About 1.5% is carried by what? Dissolved in plasma. It's dissolved as a gas in plasma. When they do PO2 saturation monitors in clinic, which one do they measure? You guys know? You ever had an O2 monitor on your finger?
Oh, yeah.
You guys know what I'm talking about?
Mm-hmm.
Yep.
O2 saturation.
Measures free oxygen, which really isn't a good measurement of how much oxygen you have in your body at all. But it gives you an idea whether somebody's going to go into oxygen distress. What's the PCO2 in here? You can see how this is important now. PCO2, 45. PCO2, 40. You're just going to move high to low. How do we carry most of our CO2? Back from the tissue. We picked it up in the tissue. It says bicarbonate. There's the big arrow. Most bicarbonate. I actually need you to know the percentages. It'll make some of the questions a lot easier. All right. Most of it comes in as HCO3. Some is bound to globin part of hemoglobin. Some is dissolved in plasma, and then a small percentage of the bicarbonate moves across this way. What is carbonic anhydrase? ACE. ACE. You see ACE, it's an enzyme. Enzymes catalyze equations, which means it speeds them up. Carbonic anhydrase is manufactured by a red blood cell, which is fascinating to me because what's missing in a red blood cell? The nucleus. Nucleus. So it's made, carbonic anhydrase as an enzyme is made before the nucleus is ejected, which means it's before it's released from the bone marrow. So we put this enzyme where we just kind of store it there. Fascinating. Most of it carbonic, bicarbonate. This is carbonic acid, and there it dissociates into CO2 with water. You can have this equation go in two directions. Second direction is at the tissue, and I already told you, this is why I like drawing this out. You may go, man, do I have to know all this chemistry? Yeah, it'll help. Certainly it'll help. 4 products of metabolism. Again, if you didn't write it down, you should have. Heat, CO2, ATP, water. And if it's exercising a lot, it might also give off what? Lactic acid, which is hydrogenized. So we can have 5 potential products of metabolism. You know your PO2s in each spot, your PCO2s in each spot, and that indicates why the flow of direction is moving. You need to understand that chloride is being exchanged for bicarbonate. That's called the chloride shift. Maintains that ionic balance in the red blood cell. Chloride shift. So I put this picture on your test, and I just whited out stuff. Whited out stuff.
So you put both of them in
And
there?
you have to fill it. I just put one. I would tell you, but I don't remember which one it was. There's pictures too. One of those 2 pictures is on the exam with some things whited out. But it's bigger than that. It's a lot bigger than that. Because this has to do with what triggers that, what triggers this right here to release. Hemoglobin and oxygen have a high affinity for each other. You guys know that? They like each other. Something has to make them unlike each other. What is it? What's the number 1 factor that decreases the affinity of hemoglobin and oxygen? Michael? Yes. Acidity and heat are the 2 factors. What's the number 1? Heat. Believe it or not, it's temperature. Temperature. Write that down if you didn't before. It's on the test. Temperature is the number 1 factor that decreases the affinity, the attraction of hemoglobin and oxygen. First question on the test. What 2 structures of the CNS regulate respiration, response to do it. That's all you need to know about neurons. You also ought to know about phonetic nerves. When you measure, and you use it in here. Central chemos. Central chemoreceptor. In the CSF are very sensitive to high CO2 and high acid levels.
And high acid levels?
Nothing on bronchitis or emphysema, even though that was in your lab. Two terms you ought to write down, they're in your notes. Hypercapnia and hypocapnia. Understand the difference of the two? Of the things I remembered, I talked about Boyle's law. The other law that made it is Bohr's law, B-O-H-R. That has to do with we've been talking about it all morning, is hemoglobin oxygen attraction or affinity. I'm looking. Covered it all. Any questions? Anything else? 8 o'clock Monday. Be online. If you need anything, let me know.